Find limits of polynomial, rational, and trigonometric function using theorems. Question number 3 in the EOT. Now we will start with this type of question where we have a piecewise function. So whenever you see that something like this means piecewise function. Question number 21. Find the limit as x approaches 2. Now whenever we have a piecewise function, it is compulsory to find the limit from the right and the left. So directly I will write underneath this limit of f of x as x approaches 2 from the left, limit of f of x as x approaches 2 from the right. Now I need to identify which part of the function is the left, which one is the right. Whenever we say left, it means less. So we are looking for when x is less than 2. So here I can see that this is x less than 2. So here I see 2x. So I say limit of 2x as x approaches 2 from the left. Now, whenever I say from the right, it means more than 2. So I'm looking for x more than 2. So here I see if x is more than 2, it is x squared. So here I will say limit as x approaches 2 from the right for, not 2x, x squared. Now, you can also think about it this way. The very first time that you see that the 2 appears, this is going to be the left. The second time the 2 appears, this is going to be the right. Now, after you have identified the functions, all you have to do in order to find the limit is direct substitution. So I'm going to substitute in the place of the x 2. So I will end up with 2 times 2, which is 4. Now here I see x squared, so I substitute 2 squared, which is 4. Now, if the limit from the right equals the limit from the left, this means that the limit exists. So the limit as x approaches 2 for the function f of x is also 2. Now we go to the next one. Again, I see a piecewise function. They want the limit as x approaches minus 1. So directly I say limit x approaches minus 1 from the left, limit x approaches minus 1 from the right. Again, first time that the minus 1 appears, this is the left, or you can say since left means less, so x is less than minus 1. So here is x squared plus 1. Now minus 1 from the right is 3x plus 1. Now I do direct substitution. In the place of x, I'm going to substitute 1. So minus 1 squared plus 1 is going to be equal to 2. Now please be careful that when you are putting this in your calculator, you need to use brackets. Brackets are very important. Now I substitute in the next one, 3 times minus 1 plus 1. That will give me minus 3 plus 1, which is minus 2. Now notice the two limits from the left and the right are not equal. If this happens, then we say that the limit of f of x as x approaches minus 1 does not exist. Now we go to the next one, which is question number 23. Now they want limit as x approaches minus 1. So again, we need limit as x approaches minus 1 from the left, limit as x approaches minus 1 from the right for f of x. Now, minus 1 from the left, again, where is the first time that minus 1 appears? Here. So from the left is 2x plus 1. Minus 1 from the right, second time minus 1 appears, it's 3. Now we do direct substitution. So I am going to substitute minus 1 in the place of x. 2 times minus 1 plus 1. That's going to be equal to minus 2 plus 1, which is minus 1. Now here, if you notice, there is no x to substitute in it. So what does this mean? The limit as x approaches any number of a constant is the constant itself. So the answer here is directly 3. Now I can conclude that since these are not the same, then that tells me that the limit as x approaches -1 for f of x does not exist. Okay. Now notice in question number 24, we have limit as x approaches 1. So again, we are going to say limit of f of x as x approaches 1 from the left, limit as x approaches 1 from the right. Okay. Now, I go and I look, where did 1 appear the first time? Here I see -1. Be careful. So here is 1. So this means from the left, it is 3. Now, again, 1 appears the second time here. So this is from the right. 2x plus 1. Now I find each one of these. Again, a limit as x approaches a number for a constant. So there is no variable next to the 3. Then the answer is just 3. Now here, 2x plus 1, I substitute in the x1. So 2 times 1 plus 1, that's 3. So I got the same answer from the right, same answer from the left. So this means that the limit as x approaches 1 for the function f of x is equal to 3. And the limit exists. So that's it for this type of question, which is the piecewise type of questions. Piecewise functions.